Okay, so now we'll move to our third tutorial in same class only. Here we will learn about task preemption and everything. So as you know, LED blinking and toggling here, it's like writing ABCD. That's the basic thing which we do in controller side. But it's important that you know how to do this using bare metal and using FreeRTOS also. So for that reason, these two tutorials are only based on LEDs. Now we'll move deeper inside FreeRTOS. Okay. So for that, I'll create one more task inside my CubeMX. I have already created it with name task 4. I'll just explain it to you. Let me know my screen is visible. Is my screen visible?
Yes.
Okay. Do you guys have pen paper with you?
Yes, sir.
Okay. So just write basic things. Anyway, I'll share PDF with you. But for your revision purpose, write these things. So this topic is preemption in FreeRTOS. Okay. I'm writing its name in chat box. Just give me 1 second. I have written it in chat box. Guys, I don't know what's the weather on your side, but in here it's very hot. So just keep yourself hydrated with water. Yeah. So preemption in FreeRTOS. Preemption is one of the most important concepts in RTOS. It is what allows a higher priority task to interrupt a lower priority task. We have seen that if our task is having higher priority and another task is having lower priority, so my priority task will interrupt lower priority and first higher priority task will get completed. So it is done using this concept only, preemption. So it allows the task with higher priority to interrupt lower priority and take control of the CPU without waiting for lower priority task to finish. So for example, my lower priority task is running. Okay, so my LED2, which is having lower priority, it is running. And in middle
Sir,
of
could you
that,
please repeat?
Yeah, I'm explaining it. So, for example, my task 2 is having priority low, and it is that my LED 2 is toggling. So it is in middle stage, like my LED have just turned on, and now it's time for it to get low. But in middle of that, task 1 with higher priority gets started. So what it will do, it will take control of CPU from task 2, and my task 2 will stop for that particular seconds, and my task 1 will start and it will finish. Then task 2 will start once again from where it is left. This concept is called preemption. So in this tutorial, we are going to test preemption hands-on. We will add blocking while loop also to different tasks and observe exactly how the scheduler will respond to this. So this will make this concept easier to understand, because I am just telling you and reading all these things, so you will not be able to learn. So I'll just show you with this task also. So I'll do one thing. add some delay here. Um, yeah, so we are having 4 tasks here. So I'll use 4 tests here. So I'm just commenting it so that you guys can know. Test 1. Okay. Are you able to see? So can anyone repeat what I have written just above task 1? Anyone? Just read it.
Blocking while loop in task 1.
Yeah, blocking while loop. So what we will do, we will start by adding a long blocking operation to task 1. Inside this for loop, after OS delay, we will declare a variable with name wait and set it to 50 millisecond and run an empty while loop that keeps decrementing until it hits 0. So this will, and then we will see what this long delay will do to our task 1. So this is our task 1. This is our user code. So inside this, I'll write I'll just create a variable which I have already told you with name wait. Okay. And this my GPIO is making this to toggle with delay 1000. Now after this, I'll give wait equals to 5 million. I will keep. So fine. Again, I'll create a while loop which will make our CPU to stuck. And here I will decrement my weight. Okay. That's it. Now this while loop, it will do nothing, but it will just burn CPU cycle until the counter reaches 0. During this time, task 1 will be waiting for CPU and not giving up voluntarily. So we will see whether task 1 will get affected with this while loop or not. Okay. If you have any doubt, you can ask. What this will do, my task 1 will toggle and I have added a delay here. Okay. And I want to check whether my toggling will get affected with this or not. But it will not get affected. I'll demonstrate you why it will not get affected, because this this while loop is doing nothing, just burning the CPU cycle after my task is completed. So every time my task will be completed and then my CPU will get stuck. So it will not affect. You will not understand it clearly. I'll show you in the video and then you will be able to understand it. Fine. Now I'll just I'm sharing once again a video in this our WhatsApp group. Let me know once you receive this video.
Yeah, we received.
Yeah, in that video, just focus on LED 1, that is blue LED, because we have added delay in blue LED. And tell me, what do you observe? Yeah, blue LED is LED 1. Previously, all our LEDs were toggling constantly with a respective delay. Now tell me, what do you see?
With respect to pin number for LED1, CPU runs the while loop until it's become 0.
Not give me a code example. Just tell me, what do you see in the video which I have said?
Delay blinking.
Which LED is blinking constantly?
2 and 3.
And what happens with LED 1?
After a small delay of some 5 seconds, it blinks once.
Yeah. Yes. So previously LED 1, which is blue LED, it was toggling with speed of 1000 millisecond delay. But now, while we have added this while and given some delay here, no effect is having on my task 2 and task 3. Can you see? There is no effect happening on task 2 and task 3. These tasks 2 and 3 are running without any delay, but the delay is having effects only on task 1. So my task 1 is running with some delay, but task 2 and task 3, they are running without anything. But if we will use bare metal, and there, if you create 3 tasks like toggling 3 LED, and there if you toggle LED 1 after delay of 5 milliseconds, then what happens? First, your LED 1 will toggle with 5-second delay. After that, LED 2 and LED 3 will toggle. But these things are not happening here. The delay is only effective in task 1. So your CPU is not stuck throughout the program. It is stuck only in task 1. That's why FreeRTOS is very fast and its processing speed is fast. Any problem till now? Okay. Now I'll do one more test. So for that, I'll use this block in task 3. So for that, first of all, I'll remove this from here. This also. Okay. So now my code is what it was previously. Now moving to task 2. So that's here. First, for your task 2, what's happening? What will happen here? We will add the same delay in task 3. So test 2 is here. Here, This will make your FreeRTOS concept more clear. So my first task is running as it was. Second task is same. Now we'll move to this third task. And here once again we'll do the same thing. I'll add this variable weight. Okay. And this will toggle my LED with 200. Okay, I'll do that same. Moving here, I'll create weight equals to you can check at your end also by incrementing or decrementing value of this weight, and it will work till weight becomes 0. Okay. Now, same code we have tested in our task 1, but task 1 was having priority low. Now, same code we will check in this task 3, and I think task 3 was having priority higher than task 1 and 2. What was the priority of task 3? Guys, please answer. If you don't remember, like me, just say we don't remember. Task 3, yeah. So task 3 was having normal priority. So its priority is higher than task 1 and task 2. Now just build this code. This time you will see something interesting. Once again, I'm sending one video in our group. Let me know once this video reaches you.
Yeah, Chandan. Release it.
So open this video and let me know what you see. Tell me, what do you see? Hello? Hello?
LED 1 and 2 get stuck when the third task runs.
Sorry, your voice was not clear.
LED 1 and 2 get stuck when third task runs.
Yes. So now in this task, the priority of task 3 was higher than task 1 and task 2. So what will happen? Whatever state task 1 or task 2 were, if it's time for task 3 to start, it will stop both these tasks because priority of task 3 was higher. So it stopped toggling of LED 1 and 2. So you can see LED 1 and 2, they were on for more seconds, more than 5 seconds, because delay in task 3 was for 5 seconds. And then when task 3 completed, its delay was completed, then it allowed task 1 and task 2 to complete their previous task. So for that reason, LED 1 and LED 2 were on for more seconds, and then they were getting off suddenly after 5 seconds. So that's all about preemption and priority management. We have seen 3-4 videos also regarding this. Now, if anyone have any doubt regarding this, you can ask, or we are good to wind up our session today.
Sir, I'm Jairaj here. Yeah.
Yeah, Jairaj.
See, I'm a bare metal programmer.
Okay.
See, imagine this.
Everyone here I think is bare metal programmer, and they are trying to learn FreeRTOS.
Fine, sir. See, imagine instead of using this RTOS task-based things.
Yes.
Imagine I am toggling all my 3 LEDs using 3 different timers.
Okay.
So compared to my timer, where this RTOS succeeds, what is the advantage of using this RTOS?
Your timer will not set the priority of your tasks. So once you will set your timer that it will work for 3, 4, 5 seconds or whatever time you will set, it will run continuously.
Okay.
But for example, you are having 3 tasks. One is sending your data to UART. It is sending alert indication.
Okay.
And task 2 and task 3, they are having normal working, like collecting data and everything. So in case of earthquake or something else, your device have to send this alert information quickly, because in delay of some second, any hazard can happen.
Okay.
So if you use FreeRTOS and set priority of your task, UART task, then whenever some alert will come, it will stop task 1 and task 2, and first it will send alert over UART. Okay. But if you are using bare metal and timer, in that case, if your task 1 is running, it will complete your task 1, then it will complete your task 2 using timer. After completing these 2 tasks, then only your task, it will allow task 3 to perform its alert indication and send data over to UART.
Okay. Time criticality is an advantage.
Yes. And there are many advantages of FreeRTOS over bare metal, which I have explained in our first tutorial, which was as a demo session also, like time criticality, multiple tasks, resource sharing, and all. So little by little, tutorial by tutorial, when we will cover all these topics, after completion of this FreeRTOS, you will see how it is much better than bare metal. And speaking about myself, initially also I used bare metal, but once I learned FreeRTOS. Now I do all my projects based on FreeRTOS only.
And passing and receiving the parameters between tasks is
Yeah,
possible?
resource sharing is one advantage of FreeRTOS, which we will learn after 4-5 tutorials. Resource sharing, semaphore, mutex, all things.
Okay, and then the final question is accessing the peripherals. Imagine I want to access my external interrupt. See some falling edge or rising edge interrupt through this task is possible to task scheduling.
Everything that is possible with your bare metal, it is possible with FreeRTOS. If FreeRTOS also provides some additional benefits. So everything that you are capable of doing using bare metal, you can do with FreeRTOS also. Plus some extra advantage of FreeRTOS.
Okay. And how to crack the stack? See, imagine I'm writing multiple functions in a single task.
Yeah. So for that, I have shown you while creating IOC file, check this heap size and allocate your heap data and everything accordingly.
Oh, IOC decides that.
Yeah. So from there, you can check your heap size available in your controller, and you can allocate it to your tasks accordingly.
That you shown this consumed memory you showed.
Yes. Total heap stack size 3000 something, and then my 4 tasks were taking 2500 bytes, something like that. So from there you can configure all these stack and heap things.
Fine, sir. That's all from my side, sir. Yeah.
Okay, and guys, one more thing I would like to add. Like we are in initial phase of this FreeRTOS and it's a long journey. So there will be timing conflicts for some time, like for initial 4-5 lectures, because I will need more time to complete tutorials. After that, once we are done with initial tutorials, we will be able to complete in 45 minutes to 50 minutes. So I'll update timing of lectures in group. Please try to attend with that timing. Like sometimes it will be from 6 p.m. to 7 p.m. Sometimes it will be 8 to 9, or sometimes it will be 9 to 10 also. So just make yourself available on weekend. Like tomorrow is Sunday, so I hope everyone is free. So maybe I can take tomorrow's class around 4 p.m. or 6 p.m. But I'll just inform 2-3 hours prior in our group. So make yourself a little bit available for starting few lectures. Okay. So Balmiki sir, we are good to go now.
Yeah.
I'll just wind this session.
Yeah. Okay, then we'll meet again tomorrow. Thank you.
Yeah, Balmiki sir, please remain in this meeting for 1 or 2 minutes.
Okay.
Rest of all, you can please leave.
Yeah.